talk about the asymptotes. So we have some questions, 5 questions. We will find the asymptotes of the given functions. So if you remember what is the asymptote means and how to find them, first of all, to find the asymptote questions for the vertical asymptote, we factor the numerator and denominator if it is possible, and note any restriction in the domain of the function. Reduce the expression by canceling common factor in the numerator and denominator, and note any values that cause the denominator to be 0 in this simplified version. These are where the vertical asymptotes occur. Note any restriction in the domain where asymptotes do not occur. These are removable discontinuities. In order to find the horizontal asymptotes, so we have horizontal asymptote of a rational function can be determined by looking at the degrees of numerator and denominator. If the degree of the numerator is less than the degree of the denominator, the horizontal asymptote will be y is equal to 0. And the degree of the numerator is greater than the degree of the denominator by 1. No horizontal asymptote, but we will have a slant asymptote. The degree of the numerator is equal to the degree of the denominator, horizontal asymptote at the ratio of leading coefficient. Now, whenever we have removable discontinuity, which means that when we factorize numerator and denominator, and then we see that here x plus 1 and x plus 1 common factor, we can factor out this. So in order to find the vertical asymptote, just we will check the denominator where the function is being 0. So x equals 3 will be our vertical asymptote. So since we have eliminated x plus 1 where x plus 1 is equal to 0, which means x is negative 1. So you see that negative 1, we have a hole here. That means we are removing in order to get this function will be continuous. So this function will be continuous function when we remove the negative 1. For that reason, since this is not in the domain right now, we don't have the vertical asymptote. Now let's start the questions. So in order to find the asymptotes, let's start with the vertical asymptote. So to find the vertical asymptote, the first thing is we are trying the numerator could be factorized or not. It's clear that x squared minus 3x minus 7, it's not factorized since we cannot find two numbers such that their product is negative 7 and their sum is negative 3. You know that negative 7 is a prime number, so it could be negative 7 times 1 or 1 times negative 7, but both cases their sum will not be equal to negative 3. That means that we cannot factorize this. So just we have this form, original one, and then in order to find the vertical asymptote, we are just checking the denominator where the denominator is 0. So x plus 3 is equal to 0. X is equal to negative 3 is our vertical asymptote. Vertical asymptote. And you know that how to show the vertical asymptote. We just on the xy coordinate system. Now negative 3 it's here, and then what we say, we just put the dashed line. Okay. Now what about the horizontal asymptote? Since the degree of the numerator is greater than degree of the denominator, we do not have horizontal asymptote. No horizontal asymptote. I mean, since it goes the infinitive. Now, but since the degree of numerator is equal to 1 plus degree of the denominator, we have here slant asymptote. So to find this slant asymptote, what are we going to do? We will use polynomial division. So let me show you here by cleaning this 1 minute. continue now. By using the polynomial division, where x plus 3 divides x squared minus 3x minus 7. So you know that our aim is to eliminate x squared here. To do this, if I multiply by x times x will be x squared, x times plus will be 3x, and then if I subtract them side by side, so x squared minus x squared will be 0, negative 3x minus positive 3x, it will be negative 6x, and negative 7 directly copy down since there is no number to operate. And then our aim is to eliminate negative 6x. So to do this, if I multiply this by 6 times x will be 6x. But I have to subtract at the end. So for that reason, instead of positive 6, I should say here, negative 6. So I have to multiply by negative, not positive. So if I multiply by negative 6 times x will be negative 6x, negative 6 times 3 will be negative 18. So when I subtract them side by side, negative and negative will be positive 6 and negative 6 will be 0. Negative and negative will be positive 18 and 7, it will be 11. So this could be written as quotient plus remainder divided by divisor. So it's clear that our slant asymptote is y is equal to x minus 6. So the quotient directly we are copying here. So how can we show this slant asymptote graphically? You know that this is a line. When x is 0, y is negative 6. When y is 0, x is positive 6 somewhere here. So if I just put a dashed line, this will be my slant asymptote. Okay? So the first question is finished. So x is equal to negative 3 vertical asymptote, no horizontal asymptote. We have a slant asymptote, which is x is negative 6. So it was, if you remember, negative 3 was the vertical asymptote. So we have shown both of them at the same place. Now let's talk about the second question. When we look at the first question, the second question here, the numerator can be factorized or not. So let us think, is it multiple of x plus 4 or not? X squared plus 4x plus 16. So I can say that 2 times 8, but their sum will not be. 4 times 4, their sum will not be. And then it's clear that it is not possible. It could be just maybe, yeah, that's it. We can't factorize it. This is the final case. So divided by x plus 4. And then we just look at the denominator. X plus 4 is equal to 0. X is equal to negative 4 is vertical asymptote. That's it. We will see the other questions which we can factorize numerator and denominator, and there will be common factor, and we will factor out the common one. So this is a vertical asymptote. What about the horizontal asymptote? So since degree of numerator is 2 greater than degree of the denominator 1, no horizontal asymptote. But what we have a slant asymptote, since degree of numerator is 1 more than degree of the denominator. In order to find this, we use the polynomial division, and then we learn how to do this. If I multiply by x times x squared plus 4x, and if I subtract them side by side, it will be 16. Since degree of any number is 0 and degree is here 1, so it is finished. So slant asymptote is directly quotient itself. So if I show all the asymptotes here on the xy coordinate system, y is equal to x, which is my slant asymptote here. And then x is equal to negative 4. If I say this is negative 4, now this is now my vertical asymptote. That's it. Let's look at now third question. Here, if we remember that a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. Here, x cubed minus, instead of 64, if I say 4 cubed, it will be x minus 4 times x squared minus 4 plus 4x, sorry, and plus 16. Am I right? This is the formula. So it's plus, minus and plus. So the numerator, if I use this identity, a squared minus b squared is equal to a minus b times a plus b. So I can say that x squared minus 16 will be 4 squared. So x minus 4 times x plus 4. So the numerator will be x minus 4 times x squared plus 4x plus 16 divided by x minus 4 times x plus 4. And since I can cancel out, factor out these two things, there will be removable discontinuity when x is equal to 4. And at the beginning also, x must be different than 4, otherwise 4 squared will be 16. So when I look at this question, then vertical asymptote will be only where the denominator is 0 after the simplifying. So after the simplification, it means that x is equal to negative 4 is vertical asymptote. What about, do we have horizontal asymptote? No horizontal asymptote, since the degree of the denominator is greater than degree of the numerator is greater than degree of the denominator, which is 3 is less than 2. But what we have slant asymptote. To find the slant asymptote, we will use polynomial division as it is. So just let me clean some part here, eraser. If I clean only this part, I think it will be enough for me to make the calculation. Now, x squared minus 16 divides x cubed minus 64. If I multiply by x and x squared, x cubed, x and negative 16, negative 16x. If I subtract them side by side, x cubed minus x cubed 0, and negative 64, negative and negative positive 16x minus 64. Since the degree of the remainder is 1 and degree of the divisor is 2, it is over, finished. So where is the quotient? Quotient is here. So y is equal to x is slant asymptote. So how can I notate this? Y is equal to x, we just seen in the previous question, this was. And then what about the vertical asymptote? X is negative 4 if this is negative 4. Okay, that's it. Now question number 4. When we look at here, can we factorize the numerator? It could be only the case, maybe this, x parenthesis 3x squared minus 2, and then we cannot go further, that's it, negative x squared plus 4. And then to find the vertical asymptote, we just look at the denominator. Negative x squared plus 4 is equal to 0. So x squared is equal to 4. X is equal to plus minus 2. And then when I look at here, I can say that these two numbers make my function undefined. So I have a vertical asymptote at x is equal to negative 2 and x is equal to 4. And then what about the horizontal asymptote? Interestingly, still the degree of numerator is 3, which is greater than degree of the denominator, which is 2. So there is no horizontal asymptote, no horizontal asymptote. But since 3 is equal to 1 plus 2, which is degree of the numerator is 1 more than the degree of the denominator, we have a slant asymptote. So to find the slant asymptote, we will use the polynomial division. So negative x squared plus 4 divides 3x cubed minus 2x. So if I multiply this, first of all, x, it must be 1x, y, x and x squared will be x cubed, but this is the coefficient, is 3, so let me put it 3. So it will be 3x times this, it will negative 3x cubed, but since I will subtract them side by side, it will be positive, so one is positive, other is positive, nothing changed, so for that reason, let me put it minus. So negative 3x times negative x squared will be positive 3x cubed. Negative 3x times 4, it will be negative or minus 12x. So when I subtract them side by side, 3x cubed and 3x cubed will be 0, and then negative 2x minus negative 12 will be negative 2x plus 12, which will be positive 10x. So degree is 1, degree is 2, that means division finished, and the quotient is negative 3x. For that reason, y is equal to negative 3x is slant asymptote. Okay, and then how can I show them? Slant asymptote, when x is 0, y is 0. When x is 1, for example, when x is 1 and y is negative 3, so somewhere here, right? And when x is negative 1, y is 3, so it is here, and it is passing through the origin, but I have to use dashed line. Always we use the dashed line for slant asymptote. So this is now y is negative 3x. What about for the vertical asymptote? When it was x is negative 2 and it was x is positive 2. Now it will be my vertical asymptote. And the last question, are they same question? Yeah, these are the same question. Actually, this is not last question. Let me change the last question, guys. So let me say y is equal to, let's say, x squared minus 4x. And what can I write? If I write positive 5, negative 5, negative 5. So if I factorize negative 1 times 5, negative 5 times 1, yeah, it's okay, divided by, let me say, x squared minus 1. So this is the question. Let's say find the asymptotes. So first of all, for the vertical asymptote, to start the vertical asymptote, I will try to factorize the numerator. So how can I factorize the numerator? So it's clear that negative 5 times 1, negative 5, and negative 5 plus 1 is negative 4. So it could be written as x minus 5 times x plus 1. So when I write it, x minus 5 times x plus 1 divided by x squared minus 1 could be expressed as x minus 1 times x plus 1. In the previous question we already talked this, and then it's clear that there are common factors in the numerator and denominator. So if I simplify them, it's clear that when x is negative 1, x plus 1 is 0, which is x is negative 1, there is a removable discontinuity. And then just left x minus 5 over x minus 1 to my function. So the vertical asymptote is where the denominator is 0. It means that x is equal to 1 is vertical asymptote. What about the horizontal asymptote? So to find horizontal asymptote, I will check the degree, which is 2, and I will check the degree, which is 2. Since the degrees are equal to each other, the horizontal asymptote is ratios of their coefficients. So y is equal to 1 over 1, which is equal to 1 is horizontal asymptote. So what about do I have the slant? So I don't have the slant, no, since 2 is not equal to 2 plus 1. Definition of the slant asymptote is degree of the numerator must be more than degree of the denominator, which is not satisfied. So that's it. How can I show this? Horizontal asymptote is y is equal to 1, so I can say this is now y is equal to 1. Vertical asymptote is x is equal to 1, so this is now x is equal to 1, I can say. Yes, guys, so we have learned how to find the asymptotes. I think it is enough. So by the way, the meaning of the asymptote, you know that when you have the vertical asymptote, so the function is getting very closer and closer, very closer and closer to that asymptote, but never touch, okay? And that's the vertical asymptote. Okay, thank you for listening and watching. If you have any comment, you can write the comment part so I can help you also in the future. All the best.